So in this set of videos, we're going to cover the basic concepts of a math concept called conic sections. Conic sections involve a number of different types of shapes, but the ones that we're going to focus on are going to be circles and ellipses. And in particular, we're going to find that circular motion is something that we're going to be spending a great deal of our time with in the second semester. So this introduction is a pretty timely introduction of these types of concepts. So this first video, the one that you're watching now, is going to focus on the first element of conic sections, the circle. And when you look over here, here's a good old circle. And if I ask you to define the characteristics of all those points that are in red on this circle, what you would probably say is, well, what's common amongst them all is they are the same distance from the center. And that's the pure thing. A circle is a collection of all points that are a fixed distance from a point known as its center. So in this case, we have a circle that has that distance from the center of 2 units, 2 grid units, whatever we want to say. That distance from the center to any of the points on the circle is known as the radius. And in this particular case, our circle has a radius of 2 and it's centered at the origin. And so a formal definition of a circle is what you see right here. It's a collection of all the coordinates, x, y, that are located a fixed distance, and we should say the same fixed distance from a certain point, or a given point, excuse me. The given point is known as the center of the circle, and this fixed distance is known as the radius of the circle. So let's start building some equations of circles. And we'll start with the basic structure of a circle, which matches what we have here, where our circle will be centered at the point 0, 0 at the origin, and it'll have a radius of r. And so what you're going to see, this diagram, you're going to see it over and over again as we continue to work our way through both the end of the first semester and all of the second semester. This is what I call my bow tie diagram. You'll see why with the structure here. I give it that label, but we're going to use it over and over again in different forms and fashions. Now, what I've done here is I have a circle which has a radius of r, and what I've happened to do is highlight a bunch of different points. They're symmetrical, by the way. xy, negative xy. Notice that what? They have the same y coordinate, just one time the x value is positive, the other times it's negative. Down here, again, symmetry. Negative x, negative y is the location of this point on the xy grid, and x negative y here. And what you've also noticed is when I draw radiuses, the 4 that you see here in the different colors, and connect them to these points, they all have a distance of r. And the other thing that's very interesting about this is if I look at the distance of the right triangles that I can build here, the length of along the x-axis is always going to be x. You can see that highlighted here. And by the way, how tall is this going to be? Well, that value is going to be y. And so for each of these triangles, the Pythagorean theorem applies. The lengths of these two sides are equal to the hypotenuse when they're all squared. So what's the bottom line of what you see here? You're going to see that the equation for a circle with radius r centered at 0, 0 is nothing more than an implementation of the Pythagorean theorem. X squared plus y squared equals r squared. There's your basic circle equation. And now what we'll do as we go to our next page, we'll start working on variations of the theme. So look what I've done here. Couple more circles. I've given them again a radius of r, but now I've moved the center of the circle. Still a radius of r. And what I'd like you to notice in this case, my point, we're working just this, what we'll call the first quadrant, where the x and y coordinate happen to be positive. I'm going to still have a point on my circle called xy. When centered at the point x equals 2, y equals 1, this blue dot, still with a radius of r, I still create a right triangle. But what I want you to notice is, well, what are the lengths of these other sides of the triangle? Well, what's this distance in green? Well, it's nothing more than the amount, the x coordinate of this point, minus 2. Remember, we're already 2 over. So this overall length is a little bit shorter, x minus 2. And also, if this point is y coordinate of y, and what we're noticing is what? Right here, the y coordinate is 1 at this little red dot that I'll happen to note and make note of. What's the length from this point up to here? It's equal to y minus 1. So I have a Pythagorean theorem structure that's still in place. X minus 2 squared plus y minus 1 squared equals r squared. And I've done something similar over here. Again, a circle. Sorry for my drawing. It's not a perfect circle, but just go ahead and give me a little dramatic license here. Radius of r, but a new center. It's at the point -1, -2. And look what happens. I can still draw a right triangle. My radius is still intact. The Pythagorean theorem still applies. Well, what do we know about this overall red distance here? Well, to go from here, the y coordinate is 0. I go up to y. But what do I also know about this length right here? This little part that I just highlighted, that length is 2. What's the total distance of this red vertical segment? Y plus 2. And a similar concept applies over here. This little length from the blue dot just to the y-axis happens to be 1, correct? That's how long that is. And what's the distance from here over to here? Well, it's just simply the x-coordinate. What can I say that overall green length is? X plus 1. And so what do I come into? I come into a new Pythagorean theorem that represents this structure. X plus 1 squared plus y plus 2 squared equals r squared. And so what you're seeing, hopefully, is Pythagorean theorem and then some values in here that are based upon what? The center of the circle. And so here you get to the final equation, the standard equation of a circle that is centered at the point H, K, and has a radius of r. And if you use the examples up here, it should help you and you can see where this is coming from. The standard equation of a circle is centered at H, K with a radius of r is nothing more than x minus h squared plus y minus k squared equals r squared. Again, you can build your own right triangles and see all these pieces, but there is the standard equation. So let's do a few practice problems. Write the standard equation of a circle with the given radius and center. Well, center, x is 2, y is 1. X minus 2 squared plus y minus 1 squared equals r squared equals 5 squared. X minus 2 squared plus y minus 1 squared equals 25. My next equation, r squared is going to be, just to save myself a little bit of writing, r squared is going to be 16 in this problem, 4 squared. My h is -3, my k is 4. X minus 3, x plus 3 squared plus y minus 4 squared equals 16. And my last one, hey, centered at 0, 0. Well, let's just follow the general pattern. X minus 0 squared plus y minus 0 squared equals 3 squared. X squared plus y squared equals 9. All right. Now, one more piece to do. Let's go ahead. We're going to work backwards now. You're going to have an equation, and you're going to be asked to graph it. One piece just to add. The diameter of a circle is what? Well, let's go back and just take one of these drawings here. Let me just use my top one. The diagonal of a circle is what you do when you go from one side straight through to the other. And basically, the diameter of a circle is equal to twice the radius. So just store that away. Diameter equals 2r. X squared plus y squared equals 25. X squared plus y squared equals r squared. I know that my r is equal to 5. Do I see any x minus something, y minus something? I don't. This is centered at 0, 0. So I have a circle with a center of 0, 0, which has a radius of 5, a diameter of 2 times 5 equals 10. How do I graph this? Well, I'm going to use my units. Radius is 5. I'll go 5 units to the right. 1, 2, 3, 4, 5. I'll go 5 units to the left. 1, 2, 3, 4, 5. I'm going to go 5 up. I'm going to go 5 down. And once I do that, I'm just going to go ahead and try to draw a circle. And I've created my first circle. X minus 3 squared plus y squared equals 9. R squared equals 9. R equals 3. My center, hey, I'm seeing a minus 3. I'm not seeing anything associated with y. My center is at 3, 0. So let's go do this. Diameter, by the way, equals 6. Center at 3, 0. 1, 2, 3, 0. There is my center. Radius is 3. Go 3 to the left, 3 to the right, 3 up, 3 down. Dot all those points. And once you've done that, draw your circle. And finally, x minus 3 squared plus y plus 2 squared equals 16. R squared equals 16. R equals 4. Diameter equals 8. Center, negative 3 here. Center, 3. Y plus 2, minus a minus 2. Negative 2 is my center. So go find 3, negative 2. 1, 2, 3, 1, 2. There is my center. My radius is 4. 4 to the right. 4 to the left. 4 up. 4 down. And draw. And I've now built another circle. So what are the steps to graph a circle? Read the equation to find the coordinates of the center using the standard form. X minus h squared plus y minus k squared equals r squared. H and k represent the coordinates of the center. Identify the value of the radius of the circle. Remember, you got r squared on the other side of the equation. Take the square root of it. You get the radius. Mark the center. And then doing just like we did here, after you mark the center, move in each direction. Up, down, left, right from the center. Move up the units of the radius. And then all you have to do, draw arcs. In other words, draw a circle that'll connect those points. So this is the basic equation of a circle. Hopefully you found this relatively straightforward and a concept that you can work with. You'll find on the quiz you'll be asked to do this exact same type of work, but I think you should feel very comfortable with it as you work it.